Hello everyone, I am Aishwarya, TA of CS253, and today we will be talking about Python. Python is a widely used high-level programming language created by Guido von Rossum. It is an interpreted, object-oriented language released in Feb 1991. Python was designed with certain goals in mind. Those goals were that it should be easy, intuitive, and powerful. It should be open source. It should be understandable to a person who is not familiar with coding. And it should help in developing softwares or programs fast. So let's focus on how it provides short development time. Python programs are interpreted instead of being compiled in other languages like C, C++. Python programs are first converted to bytecode, which are then executed on Python virtual machine. This is very much similar to Java, where programs are also compiled to bytecode and runs on Java virtual machine. However, there is one difference between Python and Java. In Java, we have to explicitly compile a program using JavaC before running it on Java virtual machine. In case of Python, this is implicitly done as soon as we run the script. So the interpreted nature of Python results in fast development, but because it does not translate a code into machine code, its execution is slightly slow in comparison to compiled languages like C, C++. The next being that it should be easy and intuitive. Python helps to develop code in a much easier fashion because it removes certain conditions. For example, a variable need not be declared before using it in the program. Each statement in a program need not be end with a semicolon. And to mark the nesting of different blocks, we can use indentation. Let's look at a simple Python code. Here, in line 1, we define a equal to 10. This is different from other languages where we have to define the data type of the variable and also. Now, in Python, this is not an issue and this code will run fine. Similarly for the variables b and c. So if we want to print the values of these variables a, b, and c, we can do it here. Similarly, now let's focus on how to do operations on these variables. So in line 6, we do an integer addition, that is a and b both are holding an integer value and we do an addition and it results in an integer value itself, which is being printed here, a plus b equal to 30. What if we do an operation between an integer and a float value? So in line 7, we are doing a multiplication of an int with a float. And as you will see here, it results in a float value. Now there is one good part of Python is that the variables are not linked to any data type, which is the case in other languages. So a variable which was initially storing an int value can later on store a float value and vice versa. For example, if you see here in line 3, the variable b was storing an integer value 20. And in line 10, variable b will be storing a float value. And this is not an issue in Python. So b is now storing a float value of 3 because c was a float value. And doing a float division here will result in a float value which is being now stored in variable b. Note that this would have been an error in other languages because of the data type which was being assigned to each variable. Similarly, a variable which is storing a float value initially can now store an int value. Now let's look at indentation and how it helps for easy code writing. Before looking into this example, let's talk about this specific keyword range. Range provides a sequence of numbers starting from the starting number, which is being passed as an argument, the first argument, with an interval passed as the third argument, and it continues till the elements in that sequence are less than this middle argument. So range of 10, 30, 2 will result in a sequence of numbers starting from 10 up to 28 with an interval of 2. Also, we can use, so if the first argument is missing and it is being defaulted to 0, and if the third argument is missing, this default value is 1. So now let's look at the example in which we have multiple blocks nested. Okay. In line 4, for this I loop, range 1 will imply that I can take only value 0. Now this J loop is nested inside I, K is nested inside J, and so on. So here we do not have to mark the closing of that specific block explicitly. As soon as we end a block here, for example, if we look at line A, this is last statement of the L loop. So now we want to end this loop, so we will just reduce the indentation for the next statement. This is easy to code, and it removes the need to manage multiple curly braces, closing curly braces in case of multiple nested blocks. The third thing is that Python provides many data structures which are quite flexible and easy to use. Let's talk about two of the main data structures being provided in Python. The one is the list and the other one is the dictionary. List is like an array storing a set of elements. The good part is that these elements may be of different data types. So here in line 2, I define an empty list which is being pointed by this variable A. And now I start adding numbers in loop in line 4. So to add a number to this list, I simply call a keyword which is an append, and it will add the number to the list at the end. So I do not need to keep a track of what is the length of my array or the list here will be, and what is the index at which I want to insert, because it is by default adding it to the end. And if I now print this list A, you will see it is holding these numbers from 0 to 9. Similarly, I can use the array indexing operations, which we all are familiar with. Like for example, A of 5 will print the 6th element, and that will be 5. We can also do certain more complex operations on these data structures, like finding the minimum value, the maximum value, finding the length of these list using simple keywords like min, max, and length, which is nothing but simple plain English. Similarly, we have another data structure which is dictionary. So dictionary is very much similar to maps in C++, if you are familiar with. And now here I have a dictionary which is being pointed by this variable p, and it is having two keys. The first key being A, the second key being the P. Note that the first key is being assigned to a list, and the second key is being assigned a value which is nothing but a string. And this is not an issue in Python. So the data structures are capable of storing different data types. Similarly, we can also store these heterogeneous elements in a list. So the list A, which was being defined in line 2 and was then storing a sequence of numbers, can also store a sequence of strings. So let's see how is that possible. So see in line 19, I define another variable b, which is having a sequence of strings a, b, and c. And now I do this a equal to a plus b. So plus here is the concatenation of two lists. So a now will be a new list which will be holding all these elements. So it will be like holding the value 0 to 9, and then these three new strings, which is A, B, and C. Note that now performing operations like finding the minimum or maximum value in a list is no more feasible because of different data types in the list. The next is that code should be understandable as plain English. This was one main goal behind designing Python, and it has been completely achieved. So for example, and the reason is that it uses English keywords with similar meanings in the program. For example, if I have to define a function, I have to simply use a keyword def, and it will define a function for me. This is the name of the function head with two arguments a and b, which is just returning the sum of these arguments. No, here we haven't mentioned anything about the data type of a or data type of b or the value of the data type of the returned value, or even whether this function is supposed to return any value or not. Now let's see how we can exploit this by calling this function for different data types. So here I consider two lists, A and B, and in line 8 I will be using this function add to add two integers, which is simply calling this function to add the individual elements of this list. Or I can use this function to add to list. So if I pass lists itself as an argument to this function, it will return the concatenated list. Or I can use the same function to add to floats. I can use it to add the strings and so on. The other simple English understandable code we can see here in line 18 says that if 3 may print a, which means that if this value 3 is present inside whatever the values a are holding, then I'm supposed to print a, which is easy to understand for any person, irrespective of whether that person is familiar with Python or not. So in here is known as the membership operator. And note that this also handles so many complexities for you, like you do not have to traverse the entire array and have to access each element and compare with this value 3 to see whether that element exists in that array or not. You simply have to use this membership operator. Similarly, is the similar to equality. So we can just check whether these two are same or not. For example, B is not equal to A, so it will print B is not A, going to the else part. We can also enforce certain conditions in the code, and if they are violated, then we can stop the execution at that point itself. For example, I write assert length of A less than equal to 5. So length of A will be telling you the number of elements stored in the list A. So if it is less than or equal to 5, it's okay. But if it is violated, then this message will be displayed and the program execution will come to a halt. So for example, in line 30, since length of A is 3, it's greater than 2, the assertion will be violated. This message will be printed and it will throw an error. Okay, so now concluding our discussion today, Python is a free, open source and multi-platform language with the support of many open source libraries for different applications. Like for example, if we have to develop anything related to web, we can use frameworks like Django, or if you want to do scientific and numeric computing in Python, we can use publicly available libraries like SciPy and NumPy. And similarly for other applications like desktop GUI, software development, business applications, games, and many such more applications. In short, because of all these open source libraries designed specifically for different applications, Python has been widely accepted in the community, as it is now easy to develop an application in Python using such libraries.